All right, welcome back. Now we're going to look at some different applications for absolute value inequality. So let's go ahead and get started reading the first question. Number 11, a carpenter cuts boards that are 2 meters long. It is acceptable for the length to differ from this value by at most 0.05 meters. Write and solve an absolute value inequality to find the range of the acceptable lengths. Perfect. Okay, so we need to go ahead and define our variable. So a lot of times the variable is in the last sentence. Write and solve an absolute value inequality to find the range of the acceptable length. So what we don't know is we don't know the length of the board we're going to cut. So let's go ahead and say let x be the length of the board. All right, so we are cutting boards, right? And we want the boards to all be 2 meters long. This is what we want. This is the acceptable, okay? But when we cut each board, we try to get it 2 meters, but it doesn't always end up being exactly 2 meters long. So what we have to do is we have to find the difference of the length of our board and 2. And whenever you find the difference of those, you just subtract them together. You just subtract them, right? So here's the length of our board minus what it is supposed to be. And what can happen is when you're cutting a board, it can get too big, or you can cut it too big, or you can cut it too small. That represents that our board could either be too big or too small. So there's going to be this absolute value of this. And this is representing the distance that our board is off from what it is supposed to be. And so the value can only differ by 0.05. So that difference between our board and what the board is supposed to be, it can only be off by this much. Now that difference cannot be more than this, okay? So that means that this difference has to be less than the amount that it is off. But it says at most 0.05 meters. That means that it can equal 0.05. So this is our inequality here. So it says write and solve. So we wrote the inequality. That's the first thing you have to do. The second thing is that we have to solve it, okay? So we are going to solve this. I think I'm going to take it over here to the side. And we solve it, we have to split it into 2 equations. So the first one we write just as it is. And the second one, this remains the same, but this becomes a negative. And we have to flip that sign, because we just multiplied that by a -1. Then we just solve both of these separately. And that 2 plus 0.05 is 2.05. And we do add 2 here. And we have to take the difference, and that ends up being 1.95. Okay, if you take the difference of 2.00 and you subtract 0.05 from it, that becomes a 1, that becomes a 9, 10 take away 5 is 5, 9 take away 0 is 9, drop down the decimal, and 1.95. Okay, this is that compound inequality. We know that if we have, I'm just going to graph this really quick. This is 0, here's 2, 2.05 is going to be here. It's going to be a closed circle, and x is less than that. Here, 1.95 includes, and it's greater. So this is our range, okay? So it wants us to write and solve an absolute value inequality to find the range of acceptable lengths. So our range is going to be this from the smallest value, so this would be our minimum, would be 1.95 all the way to our maximum, which would be this value here. So that would be our range of values, which is the second thing the problem asks for. Find the range of acceptable lengths. All right, perfect. Let's go ahead and look at the next example. It says, during a workout, Vince tries to keep his heart rate at 134 beats per minute. His actual heart rate varies from this value by as much as 8 beats per minute. Write and solve an absolute value inequality to find Vince's range of heart rates. And I think actually what I'm going to do, I'm going to write this 3 different ways, okay? So we're going to write range, we're going to write the min and the max, and then we're going to actually write that compound inequality, which is an and, right? So we're going to write it with the min and the max, that range, and then also with this compound inequality here as well, okay? So that's how your answers need to be written. Okay, I'm sorry, back to this problem here. During a workout, Vince tries to keep his heart rate at 134 beats per minute. His actual heart rate varies from this value by as much as 8 beats per minute. Write and solve an absolute value inequality to find Vince's range of heart rates. Perfect. Okay, we have to assign the variable. We don't know what his heart is beating, right? So his heart rate. So we'll say let x equal heart rate. So this is what the heart rate is, but we need the heart rate to be 134, right? So we're going to be looking at the difference of these values. And it can only be off by 8 beats per minute, right? But it can be bigger than 8 or it can be less than 8. That's why, because of that positive and negative nature of this, it has to be an absolute value. And then his actual heart rate differs from this value by as much as, so that means it can be 8. So that means that this difference has to be less than or equal to 8. Okay? And that is our inequality here. That's the first thing we need. The second thing we need to do is just solve it to find Vince's range, right? So I'm going to write it over here. And then we're just going to break this into 2 inequalities. The first one just stays as it is. And then the second one, we multiply by that -1, making that a -8. And we have to flip that sign. Okay, now we just solve both of these. We end up with x is less than or equal to, that would be 142. And then we add 134. X is greater than or equal to, what would that? It would be a difference for, it would be 126. Okay? And let's go ahead and graph this really quick. So if this is 0, we're going to have 126 and then 142. It's a closed circle. X is greater than 126 and x is less than 142. So that is our range. That's our min and our max. So our range our minimum value is 126 to our maximum value, which is 142. And I want you to write that compound inequality. X is greater than or equal to 126 and x is less than or equal to 142. All right, so that is all the information for this particular problem. Okay, that inequality here, and then also finding the range. All right, now it is time for you to try some of these application problems on your own. So here's problem 13 and problem 14. Okay, I want you to try to work those out. Know that you're going to have to write that value of an inequality and then give the range of values like we did. So please show all your work just like I did in the previous problems. All right, so here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work these problems out. When you get done, press play and we'll talk about them together. All right, see you in a bit. All right, we're back. Let's see how you did. So it says, Maya thinks of a secret number. She says that her secret number is more than 11 units away from 50. Write an absolute value inequality that gives the possible values of Maya's number. All right, so do we know her number? We don't. So we're going to say let X equal Maya's secret number. And what do we know about it? We know that 50 is kind of that central, it's around 50, okay? So we don't know her number, but we know it's around 50. And so we need to find the difference of those two values. And it's going to be away from 50 by 11 units. That means this difference is going to be, and we have to, it could be plus 11 or minus 11, so it needs to be that absolute value. And it says, she says that her secret number is more than 11 units away. So that means this difference is more, it's bigger than 11, so we know that it's more than 11 like that. Okay? So let's go ahead, and that is our inequality. And now we're just going to solve it. Okay, so we're going to split it into two different inequalities here. And this is going to be a negative 11. And whenever we make this a negative, we have to flip that sign. And then we just solve. That would be 61. And that would be, take away 10 would be 40, and 1 would be 39. All right, so I'm just gonna go ahead and graph this and see what I'm dealing with. So 39, it says X is less than 39, and here's 61, and open circle, it's greater than 61, so that we're definitely dealing with an OR problem. So we're gonna say that the range of values is going to be X is less than 39 or X is greater than 61. And there we go. There we have our inequality, and there we have our possible values that Maya's number can be. Anything less than 39 and anything greater than 61. All right, so if you got that right, wonderful job. Okay, let's look at the next one. It says that the boxes of cereal are supposed to weigh 15.3 ounces each. A quality control manager finds that the boxes are no more than 0.4 ounces away from this weight. Write an absolute value inequality that just gives the range of possible weights of the boxes. So what is the thing we don't know? Well, we don't know the weight of the box. So let's say let X equal weight of box. But do we know what the boxes are supposed to weigh? They're supposed to weigh 15.3. But ours weighs this amount, we don't know. So we're gonna look at the difference of the two. And the difference of these two numbers, these two boxes, they can only be off by 0.4 ounces, okay? And it can be plus 0.4 or minus 0.4, so we have to make this an absolute value. I'm going to read to figure out the sign. It says a quality control manager finds that the boxes are no more than. So no more than. So that means this difference is no more than 0.4. So it can't be any more than this. So that means this has to be less than, but it can't be any more than this, which means it could equal 0.4. Okay, so there is our inequality here. And now we just need to go ahead and solve it. So I'm rewriting it over here. And then what we need to do is split it into 2. So we're going to have x minus 15.3 is less than 0.4. That, we just drop it and it stays exactly the same. And for the second one, it's going to be a negative 0.4, which means we have to flip that sign. Okay, now we add 15.3 to both sides. We end up with 15.7. And we add 15.3 to both sides here. And, oh, this is plus. Okay. Oops, plus, okay. So the difference of those two numbers would be a positive 14.9. Okay, so then we graph it and we have 0 here. We got 14.9. It's a closed circle. It's greater than, so it's going this way. Then 15.7 is over here. And that's also closed, and it's going this way. So we have an and problem, right? So our range, we have our minimum value, which is 14.9, and it goes all the way up to our maximum value of 15.7, and we're going to write that and problem, right? So 14.9 greater than or equal to x is greater than or equal to 15.7. So there is our answer right there. So if you got all of those right, yoke nikimashita, you did a wonderful job, and we will see you next time.